Now I'm going to talk about circular motion. Circular motion is just something that's orbiting in circle. An example is a satellite orbiting the Earth, or a plane turning itself around in circles. Okay, so these are what we call circular motion. Now, mathematically speaking, this happens at a very specific condition, and that condition is when the velocity of that travel is perpendicular with the net force. What does that mean? Well, we have this satellite that's going in this way right now, right? Well, it's being pulled to the center of the Earth with a certain force, and that's a net force on this because there's no other force acting on it. So that's what we mean when there is a circular motion. This is also the same with a plane. On a plane, we have the weight force, okay? But we also have something called the lift force, right? And, well, the velocity is coming straight on, right? What's going to happen is I can divide the lift force into L sine theta, L cos theta, right? And so L sine theta is supposed to be equal to W, because if it isn't, it's still going up and down, right? If I'm saying it's not, then these two are equal to each other. Now what's left? The net force is L sine theta. And L sine theta, let me bring this down. L sine theta is perpendicular with the velocity. That means I achieve something called a circular motion where the object travels like that. Okay? And I'll show you more in detail a bit later. Okay? Now, here's something where I introduce you to called centripetal force. And a lot of people get confused. This is not a type of force. We've already done a lot of types of forces. We did weight force, friction force, normal force, tension force, right? All of these types of forces we did, right? At a certain condition, they can become centripetal force. What do we mean by centripetal force? That is the net force that's going towards the center of the Earth. Okay? So that is what we characterize as centripetal force. These are not types of centripetal forces, but rather a condition. Okay? So some forces that can become centripetal force is a lift force that I just talked about. The lift force, if I were to draw a free body diagram, that's it. There's lift and weight. That's it. There's no other types of forces involved in this, right? However, if I were to split this into two, I get L sine theta, L cos theta, right? And W is equal to L sine theta, because the plane is not going up or down. It is not accelerating up or down, which means that it is going to turn because there's a net force. That's actually the net force going towards the center of this rotation. Another example is a pendulum, right? If I were to swing it around, what happens? Well, in this case, I have a tension force, okay? So that's going to be the tension force, T, right? And I'm going to have a weight force. Now, is it going up and down? No, it's not. It's going in a circular motion, which means that the tension, the y component of the tension, T sine, let's say that's theta, T sine theta has to be equal to W. They cancel each other out. What I'm left with is T cos theta, okay? And that's the component that would induce that centripetal force, okay? And so it would go in a circular fashion because this net force is perpendicular to the velocity, okay? Another example is normal force. How can normal force be a centripetal force? Well, if I have this scenario where a ball is rotating around a bowl, okay? Well, remember that the normal force is always perpendicular to the surface. In this case, it is this. It is perpendicular to this surface, right? Now what's happening? Well, I have the same way, I have a weight force. That's being counteracted by the y component of the normal force, which is just n sine theta. What I'm left with is a net force equal to n cos theta. And so the centripetal force would be n cos theta. Another example is friction. Well, how can friction be a centripetal force? How can it make something turn? Well, cars use that. Cars use the friction between the rubber of the tire and the road. That's how we turn. So you can see here that the velocity is going this way, but the friction would be going at complete perpendicular to the velocity. And this can make the car turn this way. Well, another one is, well, this is a normal force, but giving a real life example. If you've ever seen a NASCAR racing, you would see that there's a huge curved bank, okay? And this makes the car turn more easily. Why? Because the resultant force has a component, r sine theta, that's able to make it turn in a circular motion. Okay, so now let's get to the math part. Okay, when we say centripetal acceleration, right, this is just, by the way, F is equal to ma. Okay, so this is just force divided by m is equal to acceleration. The centripetal acceleration can be expressed as v squared over r. V is the velocity of the object, and r is how far it is away from the center of rotation. Okay, so that is acceleration. F is ma, so you just multiply by m. And we can use this for various reasons. If I know 3 of them, then I can find the 4th one. If I know the force that's making it turn in a circular motion, for example, if I know the force of gravity exerted on this satellite, then maybe I can determine the velocity it will travel at a certain radius. Extremely useful for space navigation, right? So as an example, in here, as I said before, I have n sine theta, mg, right? So I have n sine theta is equal to mg, and I have the net force is equal to n cos theta, where n is the normal force, okay? So normal force is equal to n cos theta, and I can equate that to the centripetal force's equation, mv squared over r. Why would I want to do that? Well, because now I can equate the normal force to a certain velocity over its radius. So pretend that I'm given the radius. I can figure out how fast it is going around the circle when I equate that this is equal to the centripetal force. Okay, now why did I draw this out? Well, because I can actually isolate this into saying n is equal to mg over sine theta. Okay, if I plug that in here, I get mg cos theta over sine theta is equal to mv squared over r. Cancel the mass on each side, and I have a function of just angle, g, v squared, and r. Extremely useful. By the way, this was in the past exam problem. Now, another thing that we need to know in circular motion is something called period. Period is a time for one orbit, and frequency is just how many times you rotate in 1 second. So it is just 1 over period. These are all given in your equation sheet. Other things are called angular velocity. So remember that linear velocity is distance over time, right? Angular velocity is just angles traveled over a given time. So I have this velocity here. In that moment, I'm going to cover a certain amount of angle, right? So in 1 second, let's say it covers 30 degrees, right? Then angular velocity would tell me 30 degrees covered per second, okay? But officially speaking, angular velocity is radians per second. So if you don't know how to convert between angles and radians, you need to know, okay? Now, we can relate angular velocity to linear velocity quite easily. And that is just doing angular velocity is equal to velocity over its radius, okay? And the unit is rad per second. Cool. Now, other things, okay? So now let's do a practice problem. A car is traveling at a constant speed of 12 meters per second. Its wheels each have a radius, including tires, of 26 centimeter. What is the linear speed of a point on the surface of the tire? So let's see. If the car is going at 12 meters per second, that means the tires must be rotating at each point at 12 meters per second. So that is 12 meters per second. Calculate the frequency and time period of the wheel's rotation. Well, we can use these formulas that are given in your data booklet. So first, let's find the frequency. Or first, let's find the period. Well, period, I can use this equation, right? So isolate t. So that's going to be equal to 2 pi times 26 times 10 to the power of negative 2 over by the velocity, 12, which should give me 0.136 seconds. Now frequency is going to be 1 over t, so that's equal to 1 divided by 0.136, 7.35 per second. Okay? Part C. Determine the angular velocity of the wheel. I can just simply do W is equal to V over R, which is equal to 12 over 26 centimeter equal to 46 rad per second. D. Through what total angle does a wheel rotate in 10 seconds in radians? Well, I know in 1 second it covers 46 radians, so in 10 seconds it covers 460 radians. In degrees, let me just convert radians to degrees. I know that pi is equal to 180 degrees, so 460 radians is equal to 460 times 180 divided by pi. That is 26,369 degrees. That is the final answer. Okay, another one. If a rotating object completes 30 rotations in 47.4 seconds, calculate its time period. Quite easy. In one rotation, how long does it take? T is equal to 47.4 divided by 30. 1.58 seconds. Frequency is 1 over t. Last but not least, angular velocity. I can find that by, okay, in one rotation, we have 2 pi radians covered, right? One rotation is equal to 2 pi radians, right? So if I cover 30 rotations in 47 seconds, I just need to multiply by this 30 divided by 47.4. 60 times pi divided by 47.4. That gives me 3.97 rad per second. Okay? Another one, draw a free body diagram of the mass. Quite simple, we already did this. That's the weight, and that's the tension. Okay, when we say free body diagram, we only mean these main components. Don't dissect them, okay? Don't dissect them yet. Free body diagram is just the main components. Part B, calculate the centripetal force acting on the mass. Well, if this is 30 degrees, let me put it here. This is 60 degrees, T sine 60, T cos 60, and mg. Okay, mg, which is equal to 1.20 Newton. Okay, so I can first do T sine 60 is equal to 1.20. So T is equal to 1.39 newtons. Okay, T cos 60 degrees is equal to 0.69 newtons. So I have 0.69 newtons going towards the center right here. And that is the centripetal force. C, if the radius of the circle is 28.5 centimeter, what is the speed of the pendulum? I can use these equations. I have that, okay, force mv squared over r is equal to 0.69. So v squared is equal to 0.69 times it by r divided by m. Solving for that, I get 1.28 meters per second. Part 2. How long does it take to complete one cycle? Well, that's the period, right? So period, I can solve it quite easily. Period is equal to 2 pi r over v, which is equal to, that is 1.40 seconds. Okay? Now, last but not least, let's talk about non-uniform circular motion. We're not going to talk too much in detail because the IB curriculum does not place much importance to it, but there's been a lot of assumptions that we've made previously, and that is that the velocity and the force are always constant while we rotate. But this is not really the case if the rotation is in a vertical axis, and this is what I'm going to show you right now. So if I were to swing a bucket around in a vertical axis, then what happens? Well, it would feel heavy at the bottom and it would feel very light at the top, right? Well, there's a reason for this, and the reason is because we can draw free body diagram. At the top, if that's the object, it has mg coming down. And tension, remember, is a reaction force. So because there's not much tension at the top, right? So mg and a little bit of tension, force of tension. So net force, which is the centripetal force, is equal to the small force of tension and mg. Okay? But if the object is at the bottom, I have mg, which is constant, the same, but tension, which is now larger, right? So the net force is equal to force of tension minus by mg, and that is the centripetal force. This is the centripetal force. Okay, so always keep in mind that you can draw free body diagrams to solve any of the questions that show non-uniform circular motion, but I want you to always use real-life scenario and picture what happens, and that will really help you and guide you in your understanding. Alright, we're gonna stop here. I'll see you in the next one. Hey guys, thanks for watching the video. If you find these really useful, then consider giving us a like and subscribing to our channel. For questions, leave them down below in the comment and we'll try to get back to you. For more academic resources, visit our website at NovaEdgeAcademics.com. We offer one-on-one tutoring service as well as college admission strategy. Let us know what you'd like us to cover next, and we'll see you in the next video.